Thank you, and thanks everyone for showing up today. It's very heartening that we have so many people interested in security. I think some of that has to do with the news, but I like to also think it has to do with some of the features we've released recently, and you're here to find out what's new and what's different. I think it's also interesting that they put me in front of this back door, because if we have time at the end, I'd like to answer some questions, but not about back doors in security, even though they've set me up here. So yeah, today's topic is really about how to get the security you need in the cloud when you're basically used to enterprise. And enterprise has certain requirements, or enterprise has certain expectations. So what's the shift and what's the change? Again, my background is really in both product security as well as operations and infrastructure and investigations. I've done a wide swath of the security industry over 20 plus years. So I try to approach this topic from all perspectives, whether it's been auditing or whether it's been running the operations or whether it's been building the products that get audited and are used in operations. Everyone has a piece of this pie. So it's a complex set of answers, but I'm going to try to cover it all here as much as I can. Our mantra, really a bit of a takeoff of the overall MongoDB story, is to make safety easier, faster, and more flexible. So sharing really is caring in some people's minds, and so we want to make it easier for people to share. And that sometimes isn't always obvious with security. People think you're getting in the way, putting up a roadblock, making things harder, but we really want to change that so that you feel like it's safe and it's easy. Because it's safe, it becomes easy, in other words. Again, my name's Davi. Here's a picture of me, which they asked me to put up. I'm not so fond of spreading my photo around the internet, but it does happen, so you can find me easily if you want. And also, there's a book I wrote a few years ago which was based on the premise of cloud security. We called it Securing the Virtual Environment because at the time we published it, it was fairly early. 2012 was when it came out, but really it was work that we did from 1999 to 2009, and then we worked on the book for a little bit and published it. It actually comes with a DVD, which is rare these days, I know, dating it. And then also, just the fact that it says virtual instead of cloud, I think dates it a bit. And then third, I think one of the most interesting things is people came to think of this book as how to attack the cloud. And it actually was used in a lot of courses. A lot of universities picked it up as courseware because it talked to people about how to get an exploit and escape the hypervisor and move from guest to guest within the environment. And we believed at the time that that was the best way to become used to a cloud environment, is to get your hands on and break out of it and see the risks so you could secure it. Wasn't always popular. I ended up teaching the course around the world. And in one case, in Brazil, for example, I was teaching a group of students how to break into each other's machines, and it just got so popular they asked me to leave the country. So not directly, but indirectly, they were like, okay, thanks, you can leave now. So I thought I was helping. Not everyone sees it that way, but that's really the sort of strange mantra of, like I say, we're trying to make things easier and faster, but sometimes people think we're making things scarier and we're trying to make things safer. It's not always clear which side you're on. So with that in mind, I like to use sort of analogies that come from the real world because I feel like it helps set the pace or sets the tone of what we're going to talk about today. In this case, I'm talking about a bridge because I think everyone's familiar. How many people drive across bridges on a regular basis? That's fairly common. Yeah, everybody should be like, I've seen a bridge, I've been on a bridge, I know what a bridge is. Here I'm talking about the bridge that sits in a fog, as you can see, or a cloud. And that cloud, as you may know, is made of salt water. So interesting, when you really look at it, that's an iron bridge that's being constantly doused in salt, which is corrosive. So why would you trust, essentially, this bridge, especially when you think about each tower has about 600,000 rivets. So does anybody, when they drive across a bridge, get out with their bridge assessment professional and say, okay, first I need you to really tell me whether this bridge is safe before we move into this cloud environment, this sort of a shared infrastructure now. Everyone's going to be moving on it, and everyone wants to know, is this safe to cross? I don't think anyone does that. I think everyone just assumes this has been assessed by someone, or I can trust it because of some standard of care. It literally is a salt fog. And so that's kind of scary, I think, if you really think about it too much. And most people don't think about it, which is a luxury. And that's kind of how we want to move to cloud. We want to get people to a level where they think of shared infrastructure as a bridge to something. The cloud really does allow you to get places faster and easier, even when it's dangerous or when it's got some sort of risk, because there's a standard of care that you're using. And so another way of looking at it, maybe a little bit easier and more common for some people, is a plane. There's about 60,000 rivets in a plane. So why do pilots have such an easy time taking off? They're not really going through every rivet on that plane, right? But they do have a checklist. And I think checklists get a bad name. A lot of security professionals especially like to think of checklists as mundane or boring or lower level thinking. You know, let's do the high level hacking. Let's find a flaw in a bolt somewhere, and then we're going to take it to a conference and talk about the new flaw in the new bolt. And that is good. I mean, we definitely want to know that there's a level of stress in a particular situation that's risky. But we also want to have a simple process that allows us to get on a plane or go across a bridge. And so there's an actual video that I found a while ago. And it's from the United States War Office that says how to fly the B-26. And the beginning of the video literally starts with life begins with a checklist. And it will end if you don't use the checklist. And this is fairly good advice because when you're using these infrastructure, these shared infrastructure environments where you really take for granted that they're safe, you're basically doing two things. One, you're using a checklist for normal routines. The day-to-day, you take off, you land. The other is you use a checklist for unusual situations where you have to respond very quickly and you need to know what to do in that situation. So really, when you think about cloud in our real life, whether it be a plane or a bridge, you're talking about the sort of thing that we actually have in cloud in a logical world or in cloud environments. More often than not, we get asked about a SOC 2. How many people here are familiar with the SOC 2 from the AICPA? Fair number. And the SOC 2 was really designed to make it simpler. The SAS 70 was widely abused, as you may know. It wasn't really intended to be for operations. And so the SOC 2 was created out of the SAS 70 wreckage. And it basically says, look, as we know in security, there's three things you want to know about. You want to know if your data is going to be confidential. You want to know if your data is going to have integrity. And you want to know if it's going to have availability. And so there's a simple checklist, whether it be privacy or security, that you can go through. And that's because, very simply, even experienced and smart people, even the best hackers are going to get security wrong at some point. And so use a checklist. The best pilots are going to need a checklist, right? Life begins with a checklist, and it'll end with a checklist if you don't use it. So recommend taking a look at the SOC 2 if you haven't, and if you do have a SOC 2, you appreciate why it's there. Just a side note on this, of course, there are other standards because not everyone speaks the same language. So there's an ISO standard we often talk to, there's a HIPAA standard, there's FedRAMP, there's, the list goes on and on. But bottom line is they're all very similar in that they're trying to give you a checklist that you can easily communicate in a standardized protocol. If you don't have a protocol like this, it becomes proprietary, and then you're asking me a checklist that's going to be made up by you, organized by you, arranged by you, and it really becomes sort of a time-consuming exercise. I'm also, I don't mind the proprietary, but I'm not a fan of trying to make the standards all the same. I do believe that there's different languages for different purposes, and people have slightly different priorities. So I'm not saying we should go down to one SOC 2, everybody use SOC 2. More like I'm saying, when you want to go into a cloud environment and get an enterprise-grade security checklist, it may be one of 5 or maybe one of 6 standards that you choose from. Instead of infinite, it just narrow it down to 5 or 6. That becomes manageable. They actually say that the human can generally handle about 3 to 5 things when it comes to a category. So if you think of that, so for example, if I have a slide, it should have 3 to 5 bullets. You'll remember that better. So typically in an organization, you should ask them for 3 to 5 different standards in their cloud environment, and you're probably going to be in the right general area. The list does go on and on and on and on, though. There's standards being created every day. In fact, I just got asked the other day about standards per state in the United States. So there'd be 50 different standards, and they wanted us to see if we could comply with each one of them for our cloud environment. And that was a bit of an ask. And they said, well, what if we gave you like 10 of the 50 states, and then the other ones don't matter? And I was like, still too many. So the other side of this, again, is that I'm not trying to dissuade people from setting up their own environments however they want and playing in them. I mean, I think this is very useful. And so if you want to do it yourself, very important to learn, and in fact, that's what my book is about, then you can set up something like the security services you see on the right side, in which case you would build your own LDAP server using open standards, you'd build your own KMIPS server, you'd build your own Kerberos server, you'd connect that to your MongoDB environment, you could write your apps on top of it. You can do all of this yourself, and it's a fantastic way to learn. You can build your own bridges across the, well, if you get right of way and all of the other legal hurdles out of the way, you can build your own bridges wherever you want, and you can basically learn a lot about bridges and a lot about rivets in the fog. But ultimately, that's not how businesses operate. A lot of them are saying, and this is the typical cloud discussion, let's make security less complex, let's have fewer errors. Sort of like, let's have pilots be successful, so let's get the checklist pieces ironed out, and then let's move quickly into the let's drive across the bridge instead of let's spend all our time building the bridge. So database as a service is emerging essentially as managed features with minimal configuration. And on the side of the slide with the pink and the yellow, you see all the things that you would have done prior, which now are going to be done for you in a cloud environment. There's a shift in thinking because now you have to ask, have you hardened as opposed to going through and running your own checklists? And so what would your checklist look like to make sure someone is doing the hardening in that environment? So with that introduction, now I'll talk you through basically what I think are the three. Remember I said 3 to 5 is what we can remember. So I'm saying 3 things that you should look for when you're trying to get security out of the cloud. So if you're an enterprise and you're used to security, there are 3 basic categories that you really should focus on. And when you get into the details of each, that should give you a general view of whether it's safe to move into this cloud environment. Safe for you, safe for your customers, right? So let's talk about identity and access first. Identity and access is an interesting topic because more and more people are shifting their identity in the social networks, and you have lots of different repositories of identity. But here we're really talking about how to get your identity mapped to a particular cloud environment so you can use it there. And the Phyto Alliance is an excellent example of where industry is moving. Again, we're trying to make things easy but safe. So you see here the Phyto Alliance has created the same sort of graph I'm talking about where they say it's really easy to use and it's very strong security. And they're positioning themselves in that sort of sweet spot. That's where they want to take you. Sort of an idealistic view where they want to get to, but that's a noble goal. And so really what they're framing it as is you end up with poor security and poor usability and weak security when you get down into the old laptop login. You get stronger security, but even weaker security sometimes when you go with tokens. So if you mix the two in a way that you have passwords, so something you have with, or something you know with something you have, right, token plus password, you end up in a stronger place that's easier to use. So that's sometimes people's experience. Sometimes it can also be hard to use. In fact, yesterday we had a security discussion where people were saying, I signed up for a cloud provider's token-based authentication, and it made my life so miserable I never check my mail anymore. So that's a barrier we don't want to have. We want to make sure that when we add security, you actually get things to be easier so you actually are more secure and you can use them better. So some examples of that in the cloud are default roles are closed. That makes it impossible for people to get in and just start doing things, compromise you by simply stepping into a role that exists. The role has to be enabled. So if an admin hasn't enabled it, then there's no access. So look for defaults that are closed or shut down. And that's typical in cloud because they know the risks typically of leaving things open. So if you're working with a cloud provider, they usually will require you to make some changes in order for things to happen. Right? The next thing is multi-factor authentication, which I'm talking about here with Phyto Alliance, but really it's integration with whatever factors you may want. So there's a lot of different products out there, and so you want a protocol or a standard that allows you to connect into lots of different options. So really based on your business model. And then role-based access controls for projects, users, teams. This is sort of the idea that you're going to have granular levels of control in this shared environment. So the more you talk about being in a shared environment, the more you have to talk about divvying up roles and divvying up access based on what people have to do for their business. So let's talk about that in a little more detail. Some basic checks you can do, or checklist terminology here you can look for are, do you have in-flight data encryption? Absolutely mandatory to have encryption in place. And TLS is an open standard, so everybody uses it, so that's what you should expect. We have SCRAM or LDAP for user login as the example here, where that's simply a secure challenge and response authentication mechanism or lightweight directory access protocol, right? These are, again, standards that you can look for to see if they're implemented properly and you can use against your own system. LDAP allows you as a protocol. For example, in the last session, people said, how do I get complex passwords? Use LDAP, you have a protocol. Now you can have complex passwords in your directory, and that would be how you set it. And then finally, firewalls, make sure that you have some way of controlling the network. And so there's a large discussion around what does firewall look like in this new world of database as a service. But ultimately what it means is you can only access from certain locations and the defaults are closed again. So aside from having the basic checklist, also think much more broadly around the design of the environment you're going to be getting into. And so that is sort of shared responsibility. In some regulations, PCI for example, there's actually a list of shared responsibilities. There's a matrix, a spreadsheet of what you're supposed to do versus what the provider is going to do. And this is where you start to think about, do I want to have everything behind an isolated, dedicated, private space? So even though I'm in a public shared space, do I want to set it up such that it never touches the actual internet? We're in a sort of shared private connection. So important design consideration versus some people getting into the cloud want everything public and accessible from everywhere. That's a decision you have to make. And then same for peering, really. So this really gets into, and I'll talk about it in a little more detail, how you want to think about what you're doing with your data and who's going to be accessing it. A lot of times databases are meant to only be behind the scenes. Sometimes people want to be able to expose them and have access directly to anyone working on them. So here we see network by default is closed to public traffic. This is a really good way, to, in terms of a checklist again, to walk through it. You have to explicitly allow certain IP addresses to access it. You absolutely have to have a username and password to connect to the database. And then finally, you see encryption here, not only in transit, but also at rest. And so AES is another standard that people ask for. And increasingly, people ask for AES 256. Although some cloud providers are still on AES 128, which is typically acceptable, most people as a checklist want 256 or better. And so I might as well say Google's at 128. For some reason, they have a slow rotation process. But if, again, in terms of checklists, if you have that on your list of things to ask them, they will expose, oh, yeah, we actually do have 128 in some places. And so you want to know about that. But for most people, it's good enough. And so this really just illustrates with the diagram here what we're talking about. You have your applications, and you're going to try to actually connect to the data. And so you have a layer of connectivity that you can set up. The other way to do this, of course, is to set up a VPC. And so it's a virtual private network that allows you to connect your application development to a data environment or a data platform environment. But again, you're going to have some method of authorization. And so the difference really is you're specifically calling out IPs that you want to connect from any environment versus you really have a connected environment. So peering is more and more popular as people want more and more open access. But ultimately, I think, ironically, although people are moving to peering, having an IP whitelist may be more realistic when we get to an always-on, always-connected model. You come from anywhere, and so you don't have to have a VPC set up. Just depends how you run your environment. So summing that all up, people ask all the time, what does the data flow look like when you get into cloud? How is this different from my internal? Much more complicated because now you're sharing space, and what is the data going to do when it gets into that environment? So this is essentially left and right are basically, there's a blow up on the right of a replica set, but the left is multiple replica sets. So you can see if you go sharded or unsharded, you get different paths. If you go sharded, for example, it's going to go into some query router that's going to push it across the different shards. And then each one of those shards basically can be in different zones, which is nice in the cloud to have replication across. So people ask about availability, lots of availability options there. And then you have a backup service, which can also be another zone. So you get these like massive availability gains all managed for you. And then you get massive confidentiality gains because you can actually lock down who can get in and then where your network is, right, based on your account. So integrity then just becomes the only question, and you can manage that yourself using integrity tools. So hope that's helpful, showing what the cloud looks like when you start to use it. All right, let's talk about auditing. We talked about identity. Now we're going to move into what it looks like to audit your environment. So activity logs are a good way to think about logging in the cloud. For example, you can actually look at who has done CRUD operations. You can look at who has run database processes. So you want to look at the records, which ultimately are like a flight log. What happened over time? What's been going on in this environment? So if you can expose these records, you can sort of go back in time and look at what's been going on in the past, if you had to investigate some action that looked like it was untoward. But if you want to actually stay on top of things as they're happening, then you also want live feeds in which you can have activity monitoring with alerts or alarms. I mean, of course, you could do it on records, but that's mostly for postmortems. But if you're looking at live feeds on actions going forward, you're going to look for instant user or role modifications. You might want to look for cluster deploys. You actually might want to even look at the size of clusters changing. I mean, when I say deploys, I mean like some people used to think when a database got bigger, that was success. Inherently, larger is better. And that's a very primitive way of looking at things. From a security perspective, we might think, what if larger is bad? And so you might dig in and you find, oh, somebody's actually siphoning all of my credit card data and putting it into the database. It was a marketing database, so growing looked good because we have more contacts, for example. Marketing grows, more people must be good. But if you go and look at the actual data, you see those aren't contacts, those are PAN, right? So payment account numbers. If those are payment account numbers, you're in violation of PCI, and you have a major asset problem because now you have to figure out who's dumping it into that. And oftentimes, people don't even monitor in that way, so they only see that large database when it starts to exfiltrate. Terabytes of data start leaving, they go, where's that coming from? Oh, it's coming from this massive database. What's in the database? Oh, it's actually sensitive data. So you have to look for cluster deploys, scale, size, changes in those ways. And think like a hacker, you think about, what if it's not good? And then termination operations, obviously. In some cases, you want to make sure that when people are downsizing, the opposite of up, it could be bad too. What if someone's coming in and trying to destroy databases, reduce performance, and so forth. Denial of service from inside. So activity logs are very useful. And in that sense, heartbeats are fantastic. So heartbeats, because the human eye, I just know this from a lot of operations centers I've worked with in building SOCs and NOCs. If you have pie charts and you have columns, those are really great for executive briefings and presentations because they're colorful, they're engaging, they're really useful for showing that you have something that's interesting. But for the day-to-day, you get totally bored by pie charts. In fact, if I come in at 8 a.m. every day and I look at a pie chart, I could not tell you if it changed. 1 degree, 2 degrees, or a percentage. But if I look at this heartbeat, I absolutely can tell instantly that something's wrong. And that's because, especially if it's a regular heartbeat, there's an irregularity. So big fan of doing monitoring and alerts through things like, how many connections do we have? How many page faults do we have? What's the network traffic look like? Baseline and unusual. Right? So what you're really looking for is full metrics on the state of the system. You're looking for notifications that are automated. You might have an actual watermark. If it goes above, that's bad. That's flooding. We want to stay below. And so you can respond to that. And then you basically combine automated alerting with scaling options. So you basically can always look for triggers. Amazon's famous for this. Lambda's famous for this. As you see traffic coming in that's really big and you identify it's not a denial of service, those are real customers and those are really going to be buying things. Security shouldn't be like, denial of service, shut it down. They should be like, well, if they're real orders, we need to scale the back end. And if the back end scales fast enough, we can take the orders. Those are classic examples of Christmas Day or Black Friday or whatever events. NASCAR I talked to once said, we have no traffic until we have a bunch of cars on the track, and then we have hundreds of thousands of people who are trying to buy things all of a sudden, and then they go away. So you want to be able to monitor in a fine-grained enough way that you can tell what good and bad are, baselines. And so you need sort of real-time activity panels sometimes to tell, what, in order for human operators to go in and look at cloud and say, what is happening in this environment? So this being hot is good versus this being hot is a breach or a denial of service attack. And so one of the most interesting things is clocks, essentially. This is one of the oldest clocks in the world. This is an Egyptian clock, which actually was just measuring the amount of water that was draining out of this. You can see the dots on the side. So sometimes you can really just sit there and watch what's happening very slowly in a clock sense to figure out what's happening in your environment. So what's your slowest operation? Why is it taking so long? Why is your memory being used? Why is there so much network in and out traffic? Why is there so much read-write? It goes back to the foundations of security, which in the early days, like I say, I've been doing this for a long time, really was about making an operation run reliably, right? So you're basically looking for anomalies. Security now has a whole behavioral analytics anomaly specialization, but really it's about operations and understanding what's happening in your environment. And that cloud can be very, very good because, of course, they're billing you essentially for all of the behavior in your environment. So there's lots and lots of metrics that you can dig into to figure out what's happening because they want to be able to bill you for lots of use. And so it's really useful to have these panels. And then, as I mentioned, behavioral analysis has become a big part of security. So you can actually go in and look for advice on how do I make my machines behave well. Now, this is really useful. And you think about it like a security person. You think, if I'm trying to get max performance out of my environment, and I'm trying to get really good operational response, low latency, those sorts of things, in a way, if you can dial it enough with an advisor, and that creates a baseline. Now you can look for the opposite. This is not operating in the way that I expected. And so you can immediately in a cloud pick up, this cluster is operating in an unusual way. And so that sort of lack of normalcy basically informs you that there is a security incident. It actually is an interesting problem because in encryption, which we'll talk about in a second, you want lots of randomness. In fact, that's the only way you can get true security because the more random it is, the less likely it can be guessed. A secret, for example, needs to be so random no one can just grab your secret. But in a cloud environment, you want to get rid of all of your randomness because you want the consistency, which creates better uptime. It creates better performance. So in a day, for example, you might launch 20,000, 40,000 instances, and they need to be super consistent because you want to be sure they're reliably launching in the exact same way. It's sort of predictability. Well, now you have some randomness issue because you want to be able to find some way to make it really possible for people to get in with a secret that has. So you have to pipe randomness into some environments as well. So this, again, it's an interesting balance between security and performance and ease of use and so forth. So behavioral advisor, though, back to the point, is really always there. It's always watching, and that's what surveillance is really about. So it's always delivering automated recommendations without really adding any overhead. So you absolutely want to have something like a monitor telling you what behavior looks like in the cloud on a regular basis to tell you whether something untoward or bad has happened, right? And then finally, if you don't want the behavioral analysis to give it to you and just wait for it, you can actually go and start exploring and interacting with your data, and you can start to see the responses and see what happens when people are actually in there. You can view information about the indexes. You can look at, really just get in and find out whether your data is what you expect it to be or whether the things that are happening aren't expected. And then finally, the ability to go in and look at backups in the cloud has really opened security to a whole new level of introspection, because in the past we had cold, hot, we used to send stuff to mountains and the tape and so forth. And so, for example, if you said, well, this looks like something happened today or even this past month, and that's sort of live data, you might want to actually know if something happened like 12 months ago. Like, a good way of looking at this is the business has sort of cycles that are semi-regular. Like, you might have quarter close, you might have end-of-year collections. And so when you're designing systems, you often had to think about, well, if I only collect a month of data, then do I really know what's going to look like at the end of year, right, when we have different behavior in the business? The same is true for attackers. If they come in January, and then they come back in December, and you notice them in December, you have to be able to go back and look to see if something happened like this in January. So the ability to query a snapshot or query an old system can help you really figure out how long an incident has been actually percolating in your system. So, and there's, what you want to find is some uniqueness, again, in a fairly standardized environment. So if you find a user that nobody knows why it was created, or if you find some role or privilege that seems different than it should in the cloud, you can go way back to prior stored events or backups and so forth. That's a bit different than it would be in enterprise. Enterprise is quite a bit slower and harder to do this with. Of course, there's a fee associated with it as well in the cloud. So I'm not saying it's free, but it definitely is available to you as something you should consider. That's very powerful. All right, so let's talk about encryption, the last piece. We talked about identity. We talked about how you're going to manage your networks and controls, right? So auditing and logging, we talked about that as well. So now we're going to talk about encryption, which for me is one of my favorite topics. It's really, really interesting at the key management level. So that's why I have a picture of keys here. I think a lot of people think of encryption as a mathematical problem, very complex, difficult, hard to understand. What does AES 256 mean versus AES 128? That's not really what encryption is about. I mean, it is for cryptographers, but for us, we're running clouds, or we're running products, and we're trying to help people connect safely. It's really about where are your keys, who has access to them. They should be strong, but really management of keys becomes sort of the key to the castle, so to speak, literally. Whoa, that's a bug. Let's try that again. Controller got a little too hot. All right, so key management has a lot of pieces to it, right? So you can actually make it as complex as you want. You could really sit here, and this is just a subset even, and this comes from one of our partners who's a KMIP provider. So key operations, there's a lot of stuff you can do. Key retiring, think of all the things you want to do to get rid of keys that are bad. Key generation, what are all the things you want to do when you create keys? And this is just like keys in your daily life, for cars, for houses, for planes, whatever it is, keys should be familiar to you. And these are sort of things that also should resonate with you, is why they're important. It should be obvious. Whether you create a key or register that you've created the key, it should be obvious to you why that's important. But let me just boil it down. In terms of what we really need to do in a cloud environment, we have to create a key and we have to rotate a key. So there's really two things that you should really look for always that are probably the most important. Key retiring, although it's important, it doesn't seem to percolate up yet as a requirement because rotation kind of takes care of that if you think about it. And you can sort of add on from there. So if you get those two pieces, you're going to get the basics. And so in that sense, when you run a database, for example, in the cloud, and you have a partner who's going to provide you a key connection on a standards-based protocol, you have the basic building blocks of controlling access to the data, because you're going to be able to have the keys in a place that is safe, controlled, a box that you're basically in charge of, and then you're going to distribute those keys into that data environment when ready. And then the data environment is going to be open and exposed only in the times that you allow that key to live in that environment, right? So this is basically how key management works to allow access to a database given a key store that has to talk to an external key store, right? So you basically have a master key that's required to open up the local key store or wallet, people sometimes call it, and then once that's open, then the data can be accessed. So fairly simple, right? Now this gets complicated because we have different roles for different levels of access. If I look at a cloud provider right now, I can tell you there's about 4 or 5 levels of key management you have to think about. There's hardware, which is basically totally abstracted. We don't even worry about it, but it is a threat model. What if someone walks away from a disk in the data center? And this happens, they take, or even an array of disks, and they send them back for repairs, and then those disks weren't encrypted. Well, that would be bad. So they encrypt the disks themselves, so that's not a problem anymore. But then above the disks being encrypted, there's sort of the volume at the operating system level. And so, what if somebody, when the system is powered down, were to just power it up and be able to go in and get the data? Also a threat model. So you encrypt the data then at the operating system level. And then you sort of go up another level. What if the operating system is encrypted and you're able to get in, but the database isn't encrypted? So once you're into the operating system and you've decrypted it, you could get into the database. So then you encrypt at the level above that, the data. You get to the collection, you get to the field, and then ultimately you get to the top level, which is really outside entirely, which you could do with this also, at the application level. So unless you have the key at the application level, everything is encrypted. Now turn that around, and it's like, if I encrypt it at the application level, then nothing below it can see anything. So I get no hardware performance optimization, I get no compression, I get no data indexing or searching, because none of the systems at the bottom level can see the data. It's just gibberish, basically, it's looking at. So this is one of the more complex problems in key management, is given the cake, essentially, of layers of encryption, what do you want to give access to so that you get the benefit of the features that can provide you? You might have, for example, compression, and this is what you typically get in the Dropbox scenario, where people say, hey, we're going to have keys to your data, but you're going to get really, really cheap storage because we're going to compress it massively. And you say, I'd rather pay for you not to compress my data. And they say, fine, so you pay a lot of money and it never gets compressed. Can't compress data they can't read, really, right? So that in mind, there are service levels that you get based on the encryption level you choose. And so what you're really thinking about here typically is, where do you want your key store control to live? As you get more control of the key store, more customer managed keys, you get less ease, but you get more decision around who has access to it. And you can really put a hard line on, I don't want these people to see my data. On the other hand, that means management. It becomes the K-MIP circle. You actually get a lot more control of all the different things you have to think about or worry about. Who has? Whereas if you go towards ease, then it's encrypted and you're compliant. Remember the checklist? You may be able to check off all the checklists because someone else is managing it for you. You can just drive across the bridge and know it's safe. So encryption service levels really do matter, and it really does come down to sort of what you're dealing with. We find people who are really worried about top secret regulated data, or PII, PHI, PCI, those sorts of things. They want more control of their keys, so they're willing to let you have the encrypted data, but they really want to manage and distribute all the keys themselves. But when people are more in the confidential space and they really just want to make sure they're complying and they don't really have to worry so much about the fine details of regulations, then they say, you know what, just handle all of the encryption. I'm really happy it's on and it's there. And I trust that the people who have access, the roles that I'm giving access to, aren't going to abuse those roles. So that's basically the breakdown. And there's a lot of differences. Again, I said, encryption, as I said, can be complicated when you look at the actual keys themselves and how things are being done. So whether it's symmetric or asymmetric, or how you sign and verify, you get differences by different provider. So you can really dig into it. Or you might just say, for example, I want AES 256, and they all do that. So rest assured that when it really becomes important enough and regulators step in, it's because enough customers have expressed concern, or researchers, there's been some community-based statement, and so all the providers are going to converge on that, which again tends to be easier than trying to figure it out yourself. When you have a service provider who's figuring out that the rivet strength in the bridge that needs to be a certain size for the salt fog, ultimately bridges are going to be built like that, and you can drive across them and they won't fall down. This hasn't been true in Oklahoma, by the way, just to make another point about my example. Oklahoma has a map that you can look at all the bridges that are likely to fall down because they haven't been fixing them. So Google Maps has literally an Oklahoma bridge liability map to tell you which ones are not safe to drive across. So just to sum it up, basically, here's a migration checklist. This is actually a customer who asked, here's our checklist, what have you got for us? And this is a real migration. It was into Azure. So these are the things they asked about, we talked about today: the log review, the security policies, the identity access controls, the encryption and key management. They also asked a lot about, the disaster recovery, the redundancy, resilience, the network workloads. There's a lot of that stuff, but really most of that becomes so abstracted when we talk about database as a service. We talk about the top layers. And the bottom layers are so easy to answer because we say, yes, of course there's, load and scale. Of course there's redundancy zones, depends on cloud provider, but all of that's sort of inherent in the idea that this is a cloud grade infrastructure that you're going to be getting into. The questions come up, we can answer them easily, but it's really more decision criteria around the top. How do you want to access your logs? What are your policies going to look like for you for data access, right? What sort of identity access controls do you want? Because there's service accounts and there's user accounts, right? So it's a little more complicated than the lower abstracted service architecture. So that basically sums it up. Hopefully now you can see why you don't check every rivet on this bridge when you go into a salt fog, right? You sort of trust that there's a certain implicit architecture there. And it's based on these three things. So if nothing else, remember that you should always check for identity and access, auditing, and encryption in the cloud. And that will pretty much get you all the way to where you need to go for the same level of security that you'd find in enterprise. At least we'll open up the discussion. If there are things you don't like, you can dig deeper. But if you get good answers on these three, then you're probably headed in the right direction, and you'll get what you're looking for. So thank you for your time, and I'll take any questions. Yes? Some do. Yeah, so that's a good question. The question basically is, do people want to keep keys themselves, in a place that they own and control, possession, ownership, lots of terms for it, or do they want to allow keys to go into the cloud provider's hands? So there's some regulations. PCI, for example, recently said you can't use cloud providers' key stores. They actually came out and made a statement that it's not considered safe to use the key vault or the so KV, right? Key vault is for Microsoft, KMS for Google and for Amazon. So they have different names. They're proprietary. There's a number of reasons you don't want to use theirs. Basically, they have control over them. You don't, and you're giving away access. And in the case of highly regulated workloads or highly secure workloads, you want to keep that master key, as I showed you in the diagram. So customers do ask for that. And that capability exists. And we use the KMIT protocol basically to do that. Some people forklift all of the keys as a temporary measure, so there's lots of workarounds. So they'll lift all the keys into a cloud provider for a temporary measure, and then they've time boxed the exposure. But a better one is that you have an API or a path, and so you can instantly revoke or you can instantly deploy, and so it's much easier to manage than doing the forklift.
Can I ask a follow-up?
Sure. Follow-up question.
How does that relate to differences between Atlas and the enterprise? So with Atlas, can I have that remote management?
Yes. So I think it's been announced. I don't know. You may see, I think it was announced yesterday maybe? Yeah, you can do that now. So it was asked, yeah, it was announced. So it was asked quite a bit, can I use my own key management? And so the answer was yes, and we just deployed it. Question in the back? So the question is, do we support privacy, or to what degree do we support privacy like GDPR regulations? We do support them. So the privacy is an interesting one because so from the EU perspective, it's a human right? It's a fundamental right to privacy. And that doesn't really manifest in very specific ways. It's more general. So for example, erasure. Can you make a request to have your data deleted? Yes, you can. That's the one way that privacy is manifest. Another way is, can you prevent it from being shared or moved without your approval? Yes. There's localization. We get asked a lot, in the cloud, can I keep things in a specific area? It's a little complicated, not very complicated, but in the cloud, service reliability tends to trump confidentiality. Availability trumps. And I try to give people the analysis of the ATM machine. Banks are fined extremely heavily if the cash doesn't come out of the machine. If you go to the ATM and you say, give me my cash, and it doesn't happen, they're in big trouble, like tons of problems. So cloud tends to take the same approach. When you want to get your data, HIPAA is the same. If you can't get your data, big problems. But that being said, some people want to make sure that you can't get your data. That's the GDPR. Make sure nobody can get my data. So it's a little tricky in that sense. But it's not that hard to say, OK, if you want your data to only be in a region, then in cloud, you can restrict it to a region. And if you say, I only want people of this region to work on the data, you can say that. The only reason I say it's complicated is because packets flow everywhere in the cloud. And it's Amazon, for example, will say at some point our US operations center packets will touch that data center. So there's still risk there, and that's where encryption comes in. So with the key management, you have confidentiality, right to erasure, and so on. So it handles all of these issues, but there's a little bit of detail in what level of privacy you're looking for. Yeah. Question?
On
the recommended level. You're asking a security person, so I would say turn it all on. Who cares about performance? But you probably have performance needs that your other people would say, like make sure it has this level of performance. So it's really up to you. I mean, it depends on what I would think down the road, 3 to 6 months. Like if you're going to have to do an investigation, set the logs to a level that you can do the investigation. Auditors are very good at saying you have to have success as well as failure logged, for example. A lot of people just try to get by with failures. You should do success too. Because someone who gets in and you miss and then repeatedly gets in and it shouldn't be is a success. So you have to monitor for more than you might think, but your auditors are going to probably inform it more than I would be able to tell you exactly. I want everything. I mean, it makes our job easier. Yeah, there's a question over there.
One more question. Yeah, how's the rotating key work in obscuring backup and restore? It's in the backup and the database is using different key.
Oh, how does key rotation work in backup?
Yeah, let's say you want to restore, but the database is different key from the backup. Or does it work that way?
The database, yes, the database has a different key. And so Ops Manager manages a different key rotation for the backups. And it has to have the key in order to do the restores. Yeah.
Also, you get the key that is related to the database and for the restore.
Well, it uses a separate encryption, separate key management, and it has to have the keys in order to do the restores.
So can you do it automatically through automation?
Yeah, you can automate the restores and backups, yeah. Yep.
Okay, let's give our speaker a big, we need to wind up here, and you may have a few minutes after this.
Yeah, thank you.